Okay, and the stream is live. Hello, welcome to Phone Doc Inc.'s YouTube and or Twitch channel. My name's Aaron Henning. I'm fixing iPhones today. Got a couple of backlights to repair. One of them is an iPhone 6, one of them is an iPhone 6s Plus. Both of them came in for issues with the backlight, so if you're looking at it just in normal sunlight or normal use, it's not going to look like the phone's even on. But upon very close inspection, it can be seen that there is an image on the screen. It's just really faint because the backlight is not activating. So, I'm going to show you how to fix that. First things first, we're going to get this powered on. We're going to start with the iPhone 6. I've already removed the boards from the phone. All I know is the 6 has no backlight. The 6s Plus has half a backlight. Beyond that, we're just going to have to figure it out together. So I'm going to go ahead and give power to this phone. And we're going to tell it to boot. So DC power supply is showing 0.2 right now. It kind of jumps all over the place during boot. The phone is booting up. Let's see if we can see it with the microscope. Can you see that? There's a little faint Apple logo right there. That means this phone is powering up. The display is actually working. LCD's probably fine. Touchscreen's probably fine. But there's no backlight, so it's really not usable. Most of the time, customers will come in and say, this phone doesn't turn on anymore. I can hear it beep, but it doesn't work. Fix it. So we say, okay, I'll fix it. All right. The iPhone 6 backlight is a pretty simple circuit. Go ahead and open up the schematic and just kind of explain it super quick. Here's a board view of it. So this is a pretty useful tool. Your whole backlight circuit is this little area here. So this coil, this IC chip, this diode, these two capacitors are your main power rail. They feed into this coil, which goes into the diode, half of the diode at least, main power supply. And then the other side is your anode, which is your main backlight power. Goes through these three caps, this little tiny cap here, goes through a little filter, which is just basically a fuse, and then to the screen. There's not a heck of a lot to it. When we go to the schematic, here it is. Look, I did so much prep work today, making sure this is gonna be quick and easy, quick and dirty. So here are those two caps that we pointed at, VCC main. They feed into this side of a large coil. That coil is just storing energy for basically transforming up into 20 some odd volts. Goes into this side of the diode and this side of the chip, the boost driver. What is Power Z doing? Pardon. Hello, I'm Power Z. I thought you might want 400 error notifications in Chinese hieroglyphics. Power Z is a really good tool. It just doesn't work all the time. Anyway, where were we? All right, so you're feeding main power rail voltage into the boost driver, into this side of this diode. On this side, this is the boost line. So within the chip, it bumps up, your 3.8 to 4.2 volts up to 22. I want to say 30 volt diode, 20 volt diode for N56. Yeah, it's somewhere in the 22 volt range, depending, of course, on the brightness setting. Then it goes through these smoothing caps. This little tiny 100 petafarad smoothing cap. I really have no idea, honestly, why that's there. I don't know what it does, but the engineers thought it was necessary. So, is it petafarad? No, that's going to be picofarad. PF, 100 puffs. So let's go ahead, and now that you fully understand the backlight circuit, let's go back to the actual phone. So on here we can see a couple of very clear indicators of what happened. If you're familiar with this repair, you will have seen exactly what the problem is also. Here's your boost driver, here's the coil, here's the diode, here's the 100 pF capacitor. Here are your 2 VCC main capacitors. Here are your 3 backlight anode capacitors. So without burying the lead, here is what happened. That little chunk of goop that I just pulled off is the coating that goes over the inside of the wire inside this coil. A coil is exactly what it sounds like. It's a probably about 10 feet of wire coiled up inside of here, and it has an enamel coating around it to keep it from shorting against itself. What happened there and why that enamel coating was hanging out outside the coil is because it melted in pretty spectacular fashion. So hold that thought. Okay. It's always good timing for a phone call. That being said, anybody else find themselves always annoyed when the phone rings? Like no matter who it is or what it's about, the phone call seems to just be interrupting whatever it is I wanted to be doing at that time. Maybe it's just me. No, it can't be. We're gonna go ahead and mount this board in a appropriate holder just because we're gonna be doing a little bit of prying, a little bit of scraping just to get all these busted components off of here. When I saw the black stuff pooped out of the coil there, I kind of thought, well, maybe this would be a good idea to illustrate why you should replace the coil when that happens. Maybe we'll do that. Maybe we'll just fix one thing tonight and it'll be a nice thorough how-to. But I've also got a 6S Plus with a half backlight, which when backlight goes out on the 6S Plus or the 6 Plus, it's pretty much always half of the backlight. It's usually not the whole thing, just because there's two backlight circuits that work all at the same time. They just work in tandem with each other. So one entire circuit runs the right side, and a whole other entire identical circuit runs the left side of the backlight. Alright, so what happened? Why did this backlight fail? As evidenced by the burnt coil that we just scraped that little poop off of, and you can still see the crack in it. The burnt diode, there's not supposed to be a dot, so you can get in any closer than that's about as far as the scope's going to zoom. But that's a burn mark. That's a totally burnt out diode. That's because your 19 to 22 volts of backlight power, instead of going to the backlight, went straight back into ground. We have a short to ground situation here. On it's always one of these three capacitors. They're all in parallel, backlight anode capacitors. And it's one of the three. So really at this point, what you really ought to do, you could inject voltage to the line and throw some freeze spray on it or throw some alcohol on it and see which one heats up first, because a short is always going to produce heat. Or you could just guess, which is what I'm going to do, because there's only three of them. So if we guess wrong, at the very least, or the very most, we're going to have to pull three caps off. Now, if we get it right on the first try, I'll probably just leave that cap off and not replace it. I've done enough of these to have seen there are really no ramifications to losing one capacitor. Now, if you take all three off, you might get some flicker that doesn't go away. They're smoothing caps, so they're taking that oscillating power input and they're just smoothing it out. It's like a battery. It's got 1 foot on ground. What I'm doing right now, I'm just going to verify. The damage makes it obvious, but for the sake of thoroughness, we're going to put the red probe on ground. I'll put my multimeter in diode mode. So we go ground to ground, you get a beep. It says 0 volt differential. This side's all ground. Ground, VCC main, 260. Now I did just heat this up, so it's probably fine. That's interesting. 250. So what it looks like happen, we probably, just by putting heat on it, we probably had like a partially short cap, and then putting heat on it kind of made it jump back into place, behave itself briefly. But 250 is way too low for this line. This one's normally around 500 on your diode reading. So just because the multimeter doesn't beep doesn't mean you don't have a short. Also, just because the multimeter does beep on other circuits also doesn't mean you have a short. So really, not any words to live by there. If you're probing your SoC or your CPU or your GPU line, your multimeter is probably going to beep, because those are low voltage, high amperage, really low resistance lines. You'll probably get on CPU, I want to say you usually get around a 70 or 80 reading. Likewise on GPU, it's very low. So I'm just hitting this underfill with air. That's really all we've accomplished up to this point, is removing underfill. It gets brittle. As you hit it with some hot air, it comes up a lot easier. Otherwise it has a real tough rubbery consistency to it. You don't want to put enough air to remove chips and reflow stuff, especially because look what we're working next to. Just look. If we put too much heat around here and we get this board so hot that everything's melting by it, that CPU, which is underfilled all the way underneath, is also going to start melting, and that's no bueno. That's a great way to end up with a completely non-functional phone after trying to fix something simple like a backlight. Once you bridge those connections, there's guys who pull up CPUs and reball them. I'm not one of those guys. At some point, I'll put the effort in and learn that particular skill. CPU reballing is I reball pretty much every chip on here. Baseband CPU, touch ICs all day, audio ICs. That's easy. NAND chips. When you get to the CPU, it's a whole different ball of wax. Not only that, the underfill makes it super difficult to pull up. You start ripping pads of them. Now, let's not lose track of what we're actually trying to do here. All right, so I pulled just picked a backlight anode cap to pull off, and I set it to the side. I'm gonna cool the board off a little bit so we can get an accurate diode reading. As accurate, as can be reasonably expected. I'm gonna blow that capacitor away. She gone. Right, so if that wasn't it, if that wasn't the culprit, then we'll pull one off a donor board and replace it. Excuse me while I fumble around gracefully. Okay. Multimeter. Ground. 311. wish we had that capacitor. $315, $309. I don't think that was it. No, because we were at about 260 and the area was considerably hotter last time I probed. I don't think that was it. Let's go on to the next one. Dun, dun, I'm on the next one. Foo Fighters fans? I wanted to go see Foo Fighters last time they passed through. They did not come near enough to where I live and where I was traveling last time. Sort of change.org petition to add New Orleans to the current Foo Fighters tour. Alright, so we're not going to blow this one away. In fact, let's just go ahead and test it right now and see what it is. OL. I think this one's probably okay too. How much you want to bet is actually, for the first time ever, this one? That would be poetry in motion. Alright, let's pull this one. I don't think that little tiny cap going short could actually kill that diode and do that much damage to the coil. Could be wrong. I don't know if there's enough throughput in that cap to actually send that much energy. Okay, so I'm not going to play it off like that didn't happen. I just bumped these little things here. These look like little not important things. Don't let them fool you. They're pretty important. Alright, so that's all three of the caps that I said are the only ones that go bad on this whole circuit. Oop, where'd you go? I heard a beep. Beeped as soon as I touched it. Oh, 460 something. 450. This is the one. That's the one that's bad. Naked capacitor should give you OL. You shouldn't get any beep. Let's test that theory. Red on ground. Ground. 550. That's what we wanted to see. That's what we needed the whole time. Okay, so worst case scenario came true. I had to pull all three to find the one that was at fault. I'm not mad, I'm just disappointed. Dun, dun, I'm on to the next one. So I got a dead board here. Looks like we've been here before. This place looks familiar to me. So one of the anode caps is already missing. That's what donor boards are for. That one's nice and loose, ready to be harvested. And where'd you go? You son of a... Seriously though, where did you go? Dude, you were right here. Wow, zero appreciation. It's fine. That's fine. You were probably a bad cap anyway. Didn't want that cap anyway. So for longer than I wanted to admit, I would just grab any old capacitor the same size from anywhere on the board and just drop it in here. Till one day, I actually looked at the schematic that I was relying on to tell me how this thing works. Oh, there's the other one. I said, gee, there's voltage ratings and tolerances listed on this component. I was putting like a 4-volt cap on a 22-volt line. I'm not proud of this, mind you. What did happen? Wow, we oh, there. I soldered the X-Acto knife to the capacitor. That's fun. Yeah, we better touch each of these just to be sure. So the moral of that rant was use the right cap, use the right resistor, use the right filter, and use the right diode. See, and then when you're probing them, of course they're gonna pinch and fly away. You know, I really didn't want that cap anyway. Did you hear a beep? Let's just say we heard a beep. Bad cap. Gross. That's nasty. Which one is this? Doesn't matter. I pinched and flew it away too. Okay, which one is this? Probably the same one. Which one is this? It's kind of dark looking, isn't it? Okay. I think we can live with that. Alright, there's more work to be done, so I'm actually just going to kind of set these to the side. I'll make a little pool of flux just to set them in, just so they don't get any wild ideas. Cats and dogs living together. Some other 1940s idiom. Donor board. And definitely both donor boards. PMSA is missing from both of them. Let's keep track of our donor boards, shall we? Okay, next thing to go, I'm going to take this boost coil out. In my experience, sometimes you can replace your blown out diode and your shorted cap and your melted coil and just leave the boost chip there. Most of the time it dies too with all the other shit that died, stuff that died around it. You can't unsay curse words. So saying stuff after you say the word you didn't quite intend to say, it's kind of pointless, isn't it? It's getting existential. So we're going to do the shotgun approach. And I might even just go ahead and pull both of these VCC main capacitors off too, just because they're going to make installing the boost driver way easier. This boost driver is definitely coming off. In fact, yeah, VCC main, you got to go. You go away. We'll set it on there. That's a good safekeeping spot. And you got to go. And alright, so here comes the fun part. At some point, while this whole area is this temperature, we need to get this underfill boost driver out. It's already loose. Let's give it a little twist. We'll twist and shout. You got to go. And we'll go ahead and get the diode now. I'm just trying to keep heat off of the CPU if I can. Okay, and the last thing that's got to go is the coil. Coil's kind of a project to remove. It's got underfill underneath it too, which actually acts more like glue than in other instances. So we'll get the whole thing melty. And I'll take an X-Acto blade and just kind of get under it like that, and half of it comes out. Hey, look, there's your coil. You wonder why it's called a coil? Oh, that's why. It's a coil. Alright, so we still need to get the solder melted. Still need to get the bottom edge of the coil disconnected. Okay, that's it. That's all for that. That's quite enough heat too. Spending that much time with that much heat next to the CPU it's the danger zone for sure. Looks like we knocked one of these capacitors loose. So we'll go ahead and tin that pad and have that one ready to put back in place at the same time we drop all the other stuff. But in the meantime, I'm gonna keep cleaning up. Keep getting all this UV conformal coating. It's a little more descriptive than the ever-present underfill. All this needs to come off. And if you think my work looks like a hot mess right now, you're not wrong. It is quite hot, and it's quite a mess. By the time we get done, it'll be cool and beautiful pretty functional. It's going to be everything you ever dreamed a backlight circuit could be. I really don't like picking underfill. I know some guys, every time they do a touch IC, they come and they pick all of this underfill out from the other side. Every bit of it. Because when you're doing a touch IC, if you get too much heat on there, you'll start reflowing through the board, through the other side. This is a two-side board. It's not that thick. So stuff will start reflowing all around it, all on the other end. And when these little caps and filters and resistors, when they melt inside the solder, just like this one did, when the solder melts inside the underfill rather, they pop loose. So yeah, that's a nightmare when that happens. And if it does, on many occasions I have replaced this entire row underneath the proximity connector, resoldered the whole thing because it all came loose. It sucks, totally sucks. But even as sucky as that is, I can't bring myself to peel away all this. What I've been doing for those is touch ICs. I'm just reballing the touch IC with a considerably lower melt paste. So the most heat that it undergoes is during removal. And if you're precise about when you remove the chip at the exact moment, it's going to come up without melting all this other stuff. You're going to get it. You got to get it as soon as it's sufficiently melted. You go before, you're going to pull pads. You wait too long after, then you're transferring heat. But I would say more often than not, if you've transferred that much heat through the board, it was done during reinstallation. And that used to happen to me when I was using new chips or reballed chips that somebody else reballed. You buy a reballed chip, you hope they put leaded solder on it, but they very well could have reballed it with the same ROHS high temperature unleaded solder as it was put on with at the factory. And in that case, you gotta use just as much heat to put it down as you did to take it up. And let's turn on the old cancer fan here. Try and prolong whatever years I have left. I'm just cleaning up all these pads. I spend a little bit more time on that BGA area so my new chip can go down nice and clean. Some new fresh solder. Ooh, that's way too much. So if you're using my video as a how-to, or as a do and don't, here's one for you. Do not put that much solder on a spot like that. And if you do accidentally, it's okay. It's okay. Slurp some back out of there. Boom. Look at that. Beautiful. I want to put all this needs my cheap leaded Radio Shack solder on it. This is going to melt at a nice, much lower temperature. However, I don't need to be using my cheap Radio Shack braid. That stuff's crap. We'll put the goot wick on it. It's real goot. You know how you can tell? Because it says so. It says so right on it. You want regular wick? Or you want your wick to be goot? Get yourself a goot wick. Why am I braiding sensitive VGA pads, you ask? Because I am an idiot. I was already here. The iron was hot. The solder was there. One thing led to another, and I braided the pads. I did a good job, though. It wasn't shitty. Could have been, but it wasn't. I'm gonna start a swear jar. I'm new to streaming. I have a foul mouth in my my everyday, especially at work. It's my only catharsis. But I would like to make videos that I don't have to ban my children from watching, if for some reason they want to watch iPhone logic board repair. So we're gonna try the clean thing. Let you know in a couple weeks how that works out. Oh, there's another. There's another. Boy, tonight's the night. Just free solder love everywhere. Everybody bridging together. Let's not make a habit of that. We don't want to encourage bridging. Oh, so I removed the coil, as we're all aware now. The only reason I wasn't going to remove the coil initially was just to illustrate what happens if you repair everything but the coil. But I'll just have to tell you about it instead. Your backlight will come on. Full power up, you'll be able to use it. But when you go to your backlight control, at some point, depending on where exactly the coil melted together, where exactly that little black stuff pooped out, where in that coil it shorted and melted, at some point, as you're adjusting the brightness, it'll stop getting brighter. And that'll be as bright as it gets. So you end up with not full brightness is all it is. First time I saw that, I was very proud of myself for fixing a backlight. Early on in the soldering game, it was probably not a night not much unlike tonight. Kind of a busy day, had to stay late and get stuff done so we could try and have a busy day tomorrow too. And I stayed and just buckled down and said, I'm fixing this. I'm going to learn how to do it tonight. not all of this, but you know, pulled the cap, replaced a diode and a boost driver, left everything else. Sure enough, phone power's on, backlight comes on, victory. I'm sitting there messing with it, just reveling in my own awesomeness. And I notice, sure enough, this backlight's not that bright. Just start, you know, shouldn't it get brighter than this? Start messing with the brightness control. It gets about halfway up the slide, and that's just as bright as it's gonna get. That's it. And I was just lost at that point. Well, I gave that one back as is, and I made some sort of excuse up. Well, the damage was deeper in the board than I could access, unfortunately, so yada yada yada. Not proud of that, but it happened. If you run a repair shop of any sort for any period of time, you're going to find yourself in that situation more than you want to. That's when your ethics come into play. You're giving back a fully repaired device. If not, do you still deserve to get paid? I don't know the answer to that. Sometimes. I think sometimes you still deserve to get paid. If you're able to save data, it's a data recovery job. The customer has to want the data that you saved. A lot of the phones I get from mailing customers are phones that they've purchased, they're wiped, and they got a real good deal on them, I'm assuming, because they have some sort of board level issue. Something like long screw damage, even when you get all the jumpers in place, put yourself in the shoes of the customer. This is a 6S boost IC. No, iPhone 6 U1502. I believe that is probably this one. Oh, what the hell is this? Is that it? No, that's not it. It's for 6S. Get back in here. Or that's another theme tonight. Anyway. Jumpy. Okay. Oh, I got myself a gift last time I was doing this. I was pulling capacitors from donor boards, water damage boards and such that have been abandoned, not knowing if they're any good. That's not it. That's for a 6 Plus. I thought I got myself a gift. But I bought some capacitors specifically for this circuit. Coil, yeah, we're gonna need that. bunches of them. Okay. Boost IC, coil, and diode. Where's the diode? I jettisoned another capacitor. Let's get the driver in place. This one. That little dot that I just put flux on top of and you can't see anymore. The dot is always going to go on the A1 position. So if you forget to look at the chip that you pulled off, you're probably screwed. But if you have a handy schematic or a board view, you can say, where's A1? Well, here's A1. So I'm gonna put my dot there. And if you put your dot there and it still doesn't work, well, your schematic was wrong, and shame on you for not paying attention. Or it's a bad chip, or you did a bad job soldering it. Diodes, coil and diode, capacitors, boost driver, coil, diode. That's all the pieces. That's pretty much the whole circuit. Diode has a line on it for the direction that it will be blocking traffic from. Oh, wow. Yeah, let's use this diode. Just put them close to each other, right? I want to say bad words right now. We have more diodes. We have many diodes. Anyway, like I was saying, a diode is, if you think of, the only way I could ever grasp how DC electricity works is to think of it like a fluid. I come from a mechanical background. I used to work on hydraulics and stuff. So a diode is like a check valve. It allows current to flow in one direction, and it blocks current from flowing in the other direction. So this diode's got a little line on the side it's blocking from. So current can pass that way. It can't go this way. The reason that's important, the reason this diode's even here, is because this is the feed side, and it takes the very same circuit and turns it into the output side. So it goes in here and it comes out this side. at 19 volts. We got 4 volts, 19 to 22 volts. You don't want to be sending 19 to 22 volts back all the way through this coil up into your main power rail. Don't do it. You don't really have an option to. I mean, I suppose you could. Yeah, you could. Yeah, you totally fuck this up by putting a jumper wire right there. That would be bad. You need a diode. Are you convinced that you need a diode yet? Should I keep talking? Alright. The coil, they put a dot on the coil for some reason. Doesn't matter. Remember, this is not an intelligent piece. It's a coil of wire. It's wire. It's a big, long wire. That's all that is. Alright, so I'm gonna try and do something fancy here and just... I got 1, 2, 3, 4, 5, 6, 7 things all kind of going down at the same time here. Let's see how they do. Put a little heat dam on the old CPU there. So I just nudged the boost driver. Since it's a BGA chip, you can't really see that great when it's seated. What it will do is, since it's a little cockeyed right now, as soon as it fully seats, it should kind of pop into place. Wiggle a little bit just now. Should wiggle a little bit more. There it goes. There it goes. Just walk right into its happy spot. That's good. That's good. Okay. That's good. This is still all very hot, still all melted, so I'll try not to touch it too much. And we're still down a cap. Let's find a cap. These damn jumpy caps, they just gotta be them. They gotta do them. Do you, baby? I found one. Let's make sure it's the right one and it's not the one that killed it last time. We could, this would be a whole different kind of stream if we did that. Okay, we'll go diode mode. Okay, yeah. Case in point. That one's got to go. Don't use that one. It's a solid wire now. I just grabbed a... Don't grab a random cap from your work area. Just do it. I found another one just now. And I thought about it. I was tempted to say, yeah, this one might work. And yeah, that's what I thought. Okay. And oh, there's one left. No, there's not. Nope. Alright, next. Okay, here we go. Must have needed a coil one day. But our caps are good. Or they're present, at least. We can test if they're good. Red on ground. 645. Oh, hot damn. Okay. 330 on VCC mirror. I wonder what's wrong with this phone. Oh, missing a home button connector. when I started Micro-Soldering, I had already been running a repair shop for 7 years, so yeah, there's a lot of stuff missing. So I started out with a pretty substantial collection of dead boards, stuff that was deemed no fix and abandoned after the customer decided they didn't want it and we weren't going to charge them anyway. All that to say, I've probably got 50 iPhone 6 boards here before I started, before pulling important stuff like this off of them. Still have plenty to learn on. That's what I would recommend if you're just getting into micro-soldering. Find yourself some dead boards. If you need to buy some, people sell them. They're out there. Get you some water damage boards, get you some no power boards. I mean, people sell iCloud locked boards because you can't do anything with them unless you're doing something really dishonest. But buy some iCloud locked boards. Get one that powers up and works perfectly. Aside from the fact that you can't get past the iCloud lock, save that one to do diode readings on, and then buy some more. Figure out what's wrong with them. Why are they no fixes? A lot of them, I bet you'll find, just have a shorted VCC main power rail. Great practice there. Do some short detection, voltage injection. You won't get a ton of practice on, common live issues. We're seeing iPhone 7 audio ICs every day now. At least one a day. We're seeing touch ICs still several per week, both mail-in and walk-in. So that kind of stuff you might not really get a whole lot of if you're buying dead boards, because for the most part, it really depends on who you're buying it from. Somebody's selling a phone that doesn't work on eBay because it's stuck on the Apple logo. It's iPhone 7 and the home button's clicking constantly. If you're crafty and quick and you're good at eBaying, you probably scoop that thing up for a pretty decent price. Do a easy audio IC repair. Put it all back together and sell it again. Or keep working on it. I wouldn't put an iPhone 7 in my pocket. I wouldn't do it. We've got a bunch of 7s and 7 Pluses that we've bought over the last couple months. And when they come in, cover your ears if you're wearing headphones. When they come in, with audio IC issues, you almost don't want to buy them because customers still needs to be able to take their iCloud and stuff off. But even if they don't show issues, buy an iPhone 7 or 7 Plus. I'm going to do an audio IC repair on it because I got to sell that to somebody. I got to put my name on it and give them some sort of guarantee it's going to work. Not going to guarantee it for a year or anything, but 30 to 90 days I think is reasonable. Give people enough confidence that you've kind of done your due diligence and checked, and to the best of your ability, it's a working phone. But I wouldn't bet on any unrepaired iPhone 7. I would not bet that it won't show audio IC issues in the next 90 days. I wouldn't do it. Same thing with the 6 Plus. If you buy a 6 Plus from somebody, use 6 Plus, it's never had Touch IC repaired, you better go ahead and do your M1 jumper before reselling it. That thing's gonna come back. If it was just audio IC, yeah, I'd probably test drive an iPhone 7 and carry it around. The bigger problem that's much more scary and sucks for repair shops and micro-solderers is the baseband CPU. Might just decide today's the day. It might just up and quit on you. There's no predicting it, there's no preventing it, and there's no fixing it. You get an internal short inside the baseband CPU, phone won't even boot anymore. Rare occasions, if you want to recover data, you may be able to get away with injecting the appropriate voltage into the affected line. Maybe. And it might boot again for you. But that's not a guarantee. From what I've seen, it's actually super hit and miss. It can work. I don't know if it was an optical illusion or if that coil just wiggled. That would be weird. Yeah, it didn't wiggle. It's on there. Okay, so there is our new shiny backlight circuit. So all we gotta do next is turn the phone back on and revel in the glory of a properly repaired circuit. Also get this all these little tags out here. I'm probably gonna dip this top half in the ultrasonic cleaner once we're satisfied it's been repaired. Stuff like this, once that flux gets enough hot air on it, it really turns into a glue. Makes it hard to plug in connectors. All these fluxes say no clean. That's not true. You should clean your flux. Don't leave it on there. It will corrode. Okay. Screen. What's going on here? Come on, Howard Z. What are you doing? Device connection status. I don't know what that means. Oh, you can't even see what I'm looking at. Guess it's not important. this video is hard to watch, leave me a comment. It's my first YouTube video. New to this whole self-promotion thing. But by all means, please criticize me. I don't know. My own ADD drives me nuts. So I can only imagine somebody not knowing me, trying to learn something useful. I'm getting sidetracked by wiping up my board holders. Whatever presents itself as super duper important right now. Okay, best way to do this. Zoom out. That's still not great, but let's prompt to boot. Okay, that doesn't look like it's a brightly illuminated backlight, but it is. Swap around. There. So the Apple logo. When you see this, you want to celebrate. When you see this for like 15 minutes, you want to do something else. So let's leave it on. I'm gonna go. Oh, you know what we can do? Oh, no. It's not very good. That kind of felt like a boot loop, didn't it? No, it's okay. Yeah, I'm eating pizza. You mad? That's a boot loop. I've not abandoned you. I'm getting a charging port and a battery. Okay. As much as I love these DC power supply squids, they're not foolproof. They're not consistently able to turn phones on and report an accurate or comprehensible battery health signal. So it's possible, and obviously I'm hopeful, that all that boot looping was just a symptom of a weird battery signal. Alright, USB is pulling 0.2, between 0.2 and 0.3 as it boots. We got a battery hooked up. So it's 0.8, 0.9, 0.95. Yeah. I'm not gonna do that. I'm not gonna be that guy. Seems like it's booting. Uh-huh. What'd I tell you? Uh-huh. Alright. The astute viewer may have seen this message. Let's see, what message? Oh. What? There we go. Unable to activate Touch ID. I'm going to restart it right now. Because the home button, because of the flux, was not plugged in all the way. Shall we tempt fate and make it boot again? You bet your ass we shall. I'm going to make this thing prove that it is not booted before it goes back in any customer's hands. I'm going to assume this thing's all jacked until it proves otherwise. Oh, is it on? Oh, God. Oh, God. Okay. I think Touch ID is fine. Here's what we really want to see. Since this phone came in for backlight issues, I want to see a full range of control. And we do. And even when you get towards the top, you get another bump, another little nudge, all the way back down. Okay, that's a fix. All right, we'll do reassembly off camera. However, don't go anywhere. Because I like to take a 10-second pause in between each phrase before getting to the point. We got a 6S Plus with that backlight! Alright. this on cooldown mode. Let's turn this off because it's just noisy as hell. A little more light on the sitch. Alright, 6S Plus. I've done no diagnosis aside from confirming that we have half backlight on the 6S Plus. So let's show what that looks like. I've heard it described all different ways. It looks like I have a dark spot. One of my corners is out. The actual symptom here is half backlight. Alright, we're going to prompt a boot. I promise it had half backlight a minute ago. Alright, and that's a wrap. Thanks for watching. Hope you learned something. Stole that from Lewis. Because he just did that on his stream and I thought it was funny. No one will ever see this one though, so I can rip him off as much as I want. Yes, I can. Alright, well, that's a freaking load of bullcrap. Let's see what we can see anyway. Alright. I mean, there's not going to be much to check. It's not a blown filter. The blown filter will not correct itself. It's an open line. It's damaged to the point of being broken in half. So when you have an open connection that's supposed to be a closed connection, it ain't gonna fix itself. Sometimes a short will come and go though. So let's go to the good old 6S Plus. 6S Plus schematic, and we'll go ahead and get 6S Plus. 6S Plus. 0048, is that really the board number? Probably not. 0048, hey, look at that. Alright. This is a 6S Plus. This is the board we're looking at. Is it right here? LCD connector, proximity connector, home button connector, power button, and camera. Our spot is up here. Remember, the Plus has two backlight circuits. So BL34 anode, BL Cat 4, BL Cat 3, BL Cat 2, BL Cat 1, BL anode. So anode and cathode describes the direction energy is flowing. So your high voltage input line is your anode. It splits off in like a Y shape through the backlight array, the LEDs, and that energy actually comes back to the board. It's like a pressurized fuel rail. I'm going to make analogies to whatever I know, and whatever way I can compare it to liquids and fluids, I will compare electricity to liquids and fluids. It's just how I make sense of it. Hopefully that helps you if you're not already familiar with how DC power and energy works. So it comes in here, it goes through pretend there's a Y-shaped split. The left side of that Y is cathode 1, the left side is cathode 2, and it comes back, hits a filter, then the other side goes to one of your backlight drivers. This side, it's your other anode 3-4, comes out this side, produced by this one. Comes back into the board through the cathode, filter, yada yada. Alright. Case in point, you see it. Okay. This is basically the same circuit as we just saw on the iPhone 6. There's just two of them, and it's in a different spot physically, but it still works pretty much the same. There's no major revisions or improvements they needed to make to it. I don't know why Power Z's not working. I won't bore you with that. Let's do this. This is U4050, so we're gonna search U. Nope. Yeah, U. U4050. Wow, good job. Good job, Adobe, you found it. Okay, this ought to look familiar. Compare this to the backlight circuit we were just looking at. God, this PDF is slow as balls. That is really difficult. The only major difference between this is instead of having one coil and one diode, you just have two of them in parallel on each circuit. So it's basically 4 times the circuit. You got 2 drivers, you got 2 coils per driver, 2 diodes per driver, and a handful of caps and stuff that go on VCC main side and then back out the anode side. Your cathodes here, you can see they come back in. They put voltage on here. 25 volts output on the anode, 0.26 volts coming back to the board on the cathode. Make sense? Capiche? Okay. So what could fail on this that would cause half of your backlight to go out? Answer is any of this shit can fail. Most of the time it's going to be one of these capacitors. If this capacitor goes short to ground, instead of this high voltage going here, it starts building up heat, building up tons of heat, and it works its way all the way back till it kills one or both diodes. Then it'll probably try and kill a coil too. I find on the 6S's you get way less coil damage, and it might be because there's 2 of them in parallel to handle that load. But you pretty much always get a bad diode. There's 2 different designs of diode on here as well. We can go ahead and take a look at. I was really hoping to find some damage here. I'm not equipped to teach the theory behind how all this works. I'm a little bit better at showing how to fix it, but what we want to see is what the hell happened. We're not going to have any like blown components, but here's our circuit. The way it's laid out in ZX Dubs. Alright. There's one driver, there's the other driver. Here's the 2 coils for this driver. Or not the coils, I'm sorry. The 2 diodes for this driver. Here's the 2 diodes for this driver. You'll recognize this diode, right? That's the one we just changed on the iPhone 6. This is also a diode. It's just a different glass body diode. I find these are way more robust. If one of these is going to melt and burn out, it's going to be this one. Likewise, this one. This doesn't look perfect to me. Doesn't look that great. what I've seen most of the time when one of these, when you get half backlight, it's this top one up here. And the reason I peeled this back is because if we look on ZXW, we got a whole bunch of test points up here. One of these corresponds with the anode. And if we look down here, this capacitor is one of our BL34 anode capacitors. So it's kind of interesting the way this junction works. You've got connector goes to capacitor, goes to filter. This side of the filter has another little cap on it and it goes back here. The way it's physically laid out under the board, if this filter gets blown, it usually melts so bad that instead of being soldered to the pad, the metal contacts are actually welded to the pad. So when it comes up, it likes to rip that pad out. There's a three-way junction under here. And what'll happen is even if you restore the connection from here to here, you will not have continuity from here to here. So if you restore the connection from here to here with a jumper or with a filter, if you rip up this pad, you will not have continuity from this capacitor, which is where it's the origin of the BL34 anode on this side of the board. You will not have any continuity from there. So this little test point comes into play in that case, because you can use it to run a jumper wire from, I usually do it from here, run it all around this little way, kind of route it that way, put it here, then you can put a filter right there, so it's still a filtered connection, and then you can run from here, run another jumper, and it's a pain in the ass, don't get me wrong. But you can do it. You can run it all the way to there. Big old long pair of jumpers. I've had to do that on several occasions just because of the catastrophic melting, burning damage that tends to take place when one of these goes out. So we're going to probe around. Let's get a diode reading on that anode line. It came in with half backlight. Now, whether or not my technician tested a new screen on it, I can't say. We have 505 on BL34 anode. What's 505? And we've got 506 on BL12, or our initial anode. There's not really going to be any repairs need to be made on here. I think more than likely the customer's screen, which was already broken, and which is why they came in. That screen is probably the problem here. I'd be willing to bet. Okay, I've got a new screen for a 6S Plus. You know, the good news is if we get full backlight on this screen, I get to go home, go to bed. That's actually not the worst thing that could have happened here. Not by a long shot. Hey, we could have had a boot looping iPhone 6 after we were putting shitloads of heat right next to the processor to fix the backlight. That could have happened. That'd be a great way to end the night. Alright, Prompt to boot. Nothing. Half backlight. We had no backlight and then half backlight. And the more I mess with the connector, now we got full backlight. Full backlight. A little bit of a boot loop here. Not super concerned with that, simply because it kind of seems like my squid output is not real kosher. As you can see, we've got a full backlight right now. Phone's on. Yeah, no, it's unable to activate Touch ID. Can we activate just touch? What is up with this thing? No touch, no touch, no touch, no touch. Okay. Let's put the original screen back on. This is an OEM original screen. This looks like probably the screen that came with the phone. Never been changed before. Prompt to boot. I'm getting a boot signature on the power supply, sort of. Sort of, not really effectively. Okay, now it's booting. I have to do something about this this eye power. Half backlight. So yeah, this is not a conventional issue here. So this side of the backlight went out earlier. Now it's this side. Then it's full backlight. Well, YouTube, I'm stumped. Twitch, I'm stumped. Waiting for it to boot all the way up. I want to see if we have touch. Let's go back to the schematic in the meantime. Let's see if we can figure out why we would have an inconsistent backlight. Any guesses? I want to start with something really stupid like trash in the connector. And running off this power supplies. Not in the cards tonight. Some days it works better than others. I don't know why that is. Let's go ahead and peel this all the way up because we're going to want to see both sides of this board since the backlight and display circuit kind of goes all over the place here. We want to look for water damage and corrosion. We've got some sort of odd discoloration on here, and it's probably inconsequential, but I just want to point it out. There's some sort of chemical, probably from the factory. It looks like it was around all this stuff, but it didn't quite make it everywhere. So maybe these are dry spots, but it's kind of all over the whole board. It's not just in the backlight area. This connector actually looks better than most. Let me get this foam off of here. We can get a better look at the components around it. It's isopropyl alcohol. Works pretty good. We're getting this foam surrounding out from around the connector. And this is what I get for diagnosing live on stream. A little cocky, a little arrogant, a little bit of throwing caution to the wind there, but most of the time, you fix enough backlights, it's pretty straightforward. This is interesting. This one might actually take some of tomorrow's brain power. I don't have much left in the tank tonight. So we're gonna do the preliminary. Is something broke or is something damaged check? We already know the answer to this. Yeah, that filter's fine. Where'd this one come out? It was this one. Nope. Not that one. Fine. I'll ask for directions. Oh, it's way up over there. Under here. This filter's fine. Let's do the thing. And I'm not just listening for a beep. I've got one eye. You can't see it. You have to trust me. You have no choice. 0, 0. Full continuity there. And ironically, I never really have trouble from this anode line. It's usually the 1-2 anode's usually pretty well behaved. that 3-4 likes to. Alright, got continuity there. Cathode lines never go out. I'm just gonna call it. Unless somehow you blow a filter, the cathode line is not gonna go out. It's gonna be the anode. Tell me I'm wrong. Even better, show me I'm wrong. That's my jam. Alright, oh well. In diode mode, you're sending electrical current, you're sending a small little bit of voltage from the red to the black. So if we put the red on the side that's supposed to be blocking, it's OL. There. You really can't see. That's probably a better angle altogether. Less of me. How's that work? Okay. Yeah, that's functional. Okay. So red, black. Oh well. Swap them around. Black, and then we're going to send to it. We got 0.179. Okay. 0.178. I think we already know the answer. The backlight circuit's fine. It's bueno. I would actually be more inclined to suspect chestnut, because it's actually kind of giving out orders for what the display needs, what areas of the display need to be powered on, more so than backlight. I mean, backlight's just doing whatever it's told, but chestnut's actually making decisions about what happens. We can go ahead and check these diodes though. You can read the board actually, see these surface tracers. We go here to here. Okay. And if we swap it around, we should get OL. Yep. And then that's gonna be tough. Yeah, never mind. Screw it. I am quite unconvinced that this backlight has any sort of damage. You know what? I mean, it's a $3 chip. Let's just swap out chestnut. Let's say we did something. And if this doesn't affect anything, we'll shut her down for the night, and we'll come back at it with a functional brain tomorrow, as functional as a brain will be tomorrow. Yeah, there you go. That's what you wanted to see. Okay. Chestnut. I got lots of chestnut jokes. So many. iPhone 6. You know what? I don't actually know if the iPhone 6 and the 6S Plus use the same chestnut, but we can find it pretty quick. Alright, TI 6CA 8 PCI. Probably not the number we need to look at. Yep, stop. Let's see, 65730 AOP. Yeah, it's the same chip. Okay, good. You stay beautiful. heatsink somewhere. There's a underfilled PMIC right here that would probably prefer not to get hosed. I'm doing this while my air heats up too. It's probably not the best way to do this. If you really wanted to spend as little time as necessary putting heat on the board, so I'm actually gonna let this hot air get nice and hot before yeah. 6 more seconds into that probably made all the difference. And my tweezers have a thin side and a fat side. Ooh, come on. Alright, and we want all this to go back where it belongs. Okay. Let's and those pads look pretty good. I think we're just gonna leave them like that and drop a new chip right on top. And I'm trying to get a little more flux. Not enough. Oh, was anybody paying attention to which way that chip was facing? Doesn't help, it's just me. Alright. More flux. We didn't really spend any time talking about chestnut, did we? What it does, how it works. There's not a lot to chestnut, honestly. Here it is, right here on the same page as backlight. VCC main comes in. It makes its own. It's got its own little loop that it creates. Don't know what that does. It's getting some I2C data from the rest of the phone. It's got an LCM power enable switch, so when the display is connected, chestnut will tell it to turn on. If the display is not connected, it's not getting that LCM to chestnut power enable signal, so it's not going to start turning on backlights and displays and everything. Just a bunch of data lines. It creates a couple of these small voltages. So 5V7 Mason, what do you think that does? Well, Mason is touch. So Mason AVDDH, AVDDR, LCM AVDDH, that's the main power rail for the actual display unit, and then 5v1 touch VDDH. So it tells the display to turn on, it talks to the display, and it provides the source power rail for the touch controllers. And in a nutshell, that's Chestnut. So if you've got a display that's not turning on, start at the connector, look for shorted caps, look for things of that nature that would be interrupting that signal. But then you start looking around on Chestnut and see, we didn't do any of that. This was just a blind guess. Partly because I'm tired and I'm gonna probably end this stream in 3 minutes. But also because it's easy enough to change and accessible enough to where we might yield results just by getting lucky. You don't learn a whole lot when you get lucky, but you do get paid. Cooling this board down. All those issues could be also caused by a partially shorted capacitor. That could be something. We didn't check any of that. Make you a deal. We'll come back to this one tomorrow. I will stream the diagnostics on a fresh brain. We'll see what we come up with. That's only if replacing Chestnut on a blind whim didn't fix it. Of course, how are we going to know if it fixed it? Okay, immediate prompt to boot, full backlight. The symptom that really has me thinking Chestnut was the lack of touch. I could have had a bad screen. I mean, that happens all the time. Not all the time, it happens often enough to definitely suspect a bad replacement part. But you combine that with overall intermittent display failures and malfunctions, I don't know. That says Chestnut a lot to me. You caught me compulsively cleaning again. Sit up straight, make my posture. We're probably not going to get a full boot. This power supply squid has recently gone downhill. I just brought it from my other shop because I didn't have one here. I think it might be time to go ahead and just get a whole new one. The new ones actually have the design of the battery connector is way nicer. It's on a little flex cable instead of this rigid board. If you were watching Twitch yesterday, you'd see on the iPhone 7 connector, the battery connector just broke off in my board. Not a big deal, it's easy to solder a new one back on, but alright, yeah, this should have booted by now. So we'll grab a battery. Oh, see. Just when you think Okay, okay, yeah, and we've got touch. Sorta. Also, this is a pretty heavily shattered screen. But we do have a fully functional backlight. Yeah, sorry, probably not gonna be streaming this one tomorrow, but we'll, I gotta test it super thoroughly. This thing can't go out like this. After working really intermittently and then just kind of taking a stab at replacing the chestnut driver there, this thing's gonna go through significant testing before it leaves the shop tomorrow, if it leaves the shop tomorrow. And I don't have any notes on whether they wanted to buy a new screen. I gotta imagine they want a new screen. Look at this. So we're gonna sell them a board repair and a screen. That's gotta happen. All right, that puts us past the 2-hour mark. No live viewers, but thank you to all my future viewers. You got to be here for the first one. I keep leaning this way instead of this way, leaning towards. Hit that like button, subscribe. I'm gonna be doing this a bunch. You're gonna learn a lot. Maybe not for me. You'll learn a lot of what not to do. But in the meantime, thanks for watching. Go forth and repair. I don't have a catchphrase yet. Tally ho.